Hi, this is Chrisferb and I'm going to review a binomial distribution example. And I'm going to solve the example three different ways. One using the TI-83/84 variant calculator, graphical calculator. The other is using a binomial distribution table. And the other is just using the formula calculating it out. And the nice thing about this is because you can solve it three different ways, you can make sure that you're correct by checking two of the ways. Okay, to get started, we're going to use the binomial formula to calculate the following probabilities for an experiment in which n equals 8 and p equals 0.6. So we have essentially 8 different times that this experiment will occur, and then the probability of success is 0.6. Find the probability that x is exactly 5 successes. Okay, so first we'll start off with the binomial distribution formula, and that is I'll explain it in just a second. Running off the page a little bit. It's px and then q and then n minus x. Okay. Okay, n is the number of observations. X is what we're looking for, and so the p is success, or the probability of success. Q is the probability of failure. So q is essentially Q is essentially 1 minus P, so it's the other side of success, it's the failures. And of course, with probability, it all should equal 1. And then we just work it out with what we have here. Okay, so we'll get started. So first what I'll do is I'll lay this out and just solve it with the formula. Okay, so we're looking for the probability of x equaling 5. Okay, so we can write it out like this. I could probably simplify it a little bit, but what we're going to do is with a Sharpie, it shows up the best, but sometimes if I don't write really particular, it's a little bit hard to see. And then .6 to the 5th multiplied by 0.4. I'm running into the other formula. That's okay. And it's 8 minus 5. Okay, I'll redraw this real quick. So it's something like this. I'll explain the exclamation marks in just a second. Actually, that should be inside the parentheses. Okay, this should be inside the parentheses. Okay, let's calculate this. What I always recommend is calculating it in parts. There's a lot of ways in the calculator, if you calculate this, that it can go wrong if you're just typing in all of the numbers. The other thing that I want to point out is the exclamation marks. It's a symbol for factorials. And a factorial is like this. If we had a factorial of 3, it would be 3 factorial would be 3 times 2 times 1. And so this ends up equaling 6. So that's what that's what the exclamation mark is factorials. So let's work this out. I already calculated out at least the parts, and the parts are like this. like I said, we'll solve this a couple ways. The binomial formula, in my opinion, is a little awkward because of all of the different ways that you can make a mistake with it. Okay, so this is the way that I would do this if I'm calculating it by hand. I do the numerator for our formula, the denominator, and then do the two sets of calculations inside the parentheses. Like I said earlier, this should actually be right inside. Okay, so once we work this all out, we end up with our answer being 0.2744. And that is for the probability, the exact probability of just 5 successes. No more than 5, no less than 5. Okay. Let's work this out on the table. To do this on the table, we have a binomial probability distribution table. This type is not cumulative. Some of them are cumulative, so you need to make sure that you know the table that you're using. Okay, so there's a couple angles to this, or a couple dimensions we could say. We have n that goes down the side, and that's R5 right there, and it goes all the way up. So in this case, we're using 8 for n. We're gonna find our n is 8, and then our 5 is right here. This is the x. In this case, it says r, but this is the 5 that we are looking for. So I'm going to zoom in just a little bit. So this is our n, it's 8, and then our x, it shows up as r on here, but this is our 5 right here, and this is the actual value we're looking for. And then what we do is we go all the way across and we find the probability. Our probability is 0.6. So we go over to 0.6, and our answer, it's a 3-digit. They may have rounded. It's 0.279. So 0.279, 3 digits. And remember what our answer was? Our answer was 0.2744. When we calculate by hand, it'll always be a little bit different than when we use a calculator and when we use a table. And that's just the way it goes. If our first 2 digits are there, that's really good. Their first 2 digits are completely accurate. Once you get to the 3rd and 4th digit, sometimes it's a little bit off just because of the nature of the beast. I'm going to back up and look at the rest of the paper. Okay. So that is how we calculate the binomial probability distribution by hand and with a table. Let's take a look on the calculator. I have an emulator, so I'm going to bring that up on the screen. And this is our emulator. Make sure that we clear it. Okay. Okay, it's on. So to do this with the TI-83/84 variant calculator, it's the same for both of them. The only issue is with certain types of TI-84s, we have a better menu to input our data. And then the 83s, you have to put commas in between the information. So I'll show you the data we're putting in. So what we do first is we go to second, and then DISTR distributions, and we end up with a bunch of really nice formulas. As you see, we have right here in front of us the binom PDF, probability density function, probability density function. And what that is it is the this has the application where we put in the data, and then it will apply the data and give us the exact number or the probability for the exact value we're looking for. Now on the next one, Binom CDF, it is a cumulative density function, and what it does is it goes and it gives us the answer for all the way up to the value that we put in. It's cumulative. So if we put in that we're looking for a value of 3 with the Binom CDF, it will give us the data from, it'll give us the answer for 0, 1, 2, and 3 all added up. So all the way up to 3. And we can use that to our advantage, which we will a little bit later. Okay, so I have the Binom PDF selected. Now I'm going to hit enter. And we're going to put in the number of trials. Our number of trials are 8, which is right here. So 8 trials, enter. Our p-value, or our probability of success value is 0.6. So we do 0.6. And our x value that we're looking for is exactly 5 in this case. Now, this is what it did. It goes and it takes it gives us a little input screen, and it takes it and it applies it to the function built into the calculator. If your calculator doesn't have the input screen, such as some of the older TI-84s or TI-83s, it will, what you do is you pull up the function and then you go and you put in it'll have, I think, the first parentheses, and you go and you put in the 8 comma, and the comma's down, the comma's right here. So you go 8 comma, then your probability of success, comma, then your 5, which you're looking for. Then you have to put the close parentheses, otherwise it'll error out on you. Okay, so this put it in for us. That's really nice. So I hit enter, and our answer is 0.2786, which is really good because it is almost identical to what we got on the table, which is number 5 all the way over to, so on the table we got 0.279 is what we have on the table. On the calculator, 0.278, and then when we do the calculation ourselves, we get 0.2744, and that just has to do sometimes with how far you go out with decimal points. So I just reviewed the basics of doing a binomial calculation with just trying to find an exact value such as 5. Thank you.